Swayam Prabha. Digital India. Educated India.
So, last class I started one example problem for 2 layer case, and I consider that the top layer is a stiff clay and the bottom layer is a soft clay or the softer clay, and where your phi value is 0 for both the cases. This is phi value is 0 and this is also 0. Okay. There will be only question and unit weight. Water table as the ground surface. This is a rectangular footing of dimension 2 meter cross 3 meter, and the H thickness is given 1 meter, and then df depth of the foundation is 1 meter. Unit weight or saturated unit weight for the top layer is 20 kilonewton per meter cube, and saturated unit weight of the bottom layer is 18 kilonewton per meter cube. So, submerged unit weight of the top layer is 10 kilonewton per meter cube, because submerged the saturated minus the unit weight of the water, and unit weight of the water is taken as 10 kilonewton per meter cube. And so, submerged unit weight of the second layer will be 8 kilonewton per meter cube, and this is the basic equation for suppose this is the basic equation for this rectangular footing, and then now we have to calculate the bearing capacity. So, now you know that this should not be greater than q t that we have mentioned. So, now q b will be the bearing capacity of the bottom layer, and that expression is given, the general expression is given, that C 2 N C 2 into S C 2, S C 2 is for the rectangular footing. For the stiff footing, these S terms are not there, it will be only C 2 N C 2, then gamma 1 df plus H in Q 2, then in gamma 2 like this. But it is, as it is rectangular footing, then you have to put this value also, this is gamma 1 df plus H, then N Q 2, then S Q 2, okay, then plus half gamma 2 B in gamma 2 and S gamma 2. Okay. Now, for this case, for this particular case, my phi 2 is equal to 0. So, my n gamma 2 that will be 0 and n q 2 will be equal to 1. Okay. And n c as per Mayer of n c 2 is 5.14, okay, because we are using the Mayer theory. So, my q b will be equal to C 2 N C 2 and this S C 2 the shape factor, and that is as per Mayer. So, these factors S C 2 N C 2 all these things, because that we will consider for the Mayer recommendation. So, that is equal to 1 plus 0.2 B by L, okay, plus gamma 1 into df plus H, that is df into H, and n q 2 is equal to 1 and S q 2 will also be 1, because if you see the Mayer table, for phi equal to 0, your K p value is equal to 1. Okay. So, my SQ value is also equal to 1. So, that is that. Now, remember that when you are applying these or converting the equation from strip to the rectangular footing, then for your basic equation you use this shape factor always 1 plus b by L, 1 plus b by L, okay, in this term. But when you are calculating QT and QB, in that time, because QT is nothing but when your foundation resting on the top layer only, okay, and QB is when the foundation effect on the bottom layer, okay. So, in that case you have to use the Mayer-Hoff original recommendation. You have to use the shape factor which is proposed by the Mayer-Hoff in the original bearing capacity equation. That table I have given, you have to take the bearing capacity factor from there. So, all these things as per the Mayer-Hoff. Okay. And another thing that here you can ask that your depth effect why it is not considered, because this depth effect is already taken care during the derivation, because these depth are already been taken care. Okay. So, that is why it is not there, because the original equation this is developed, which is those are basically for the surface footing. So, that is why the depth corrections are required, but here it is not a surface footing, it is with a depth of df, and then we have done the derivation and we take the depth effect is taken. So, but it is but for the inclined footing you can put those recommendations which is given in the original bearing capacity equation by Mayer-Hoff. So, that means that is why here when I calculate QB, we take the shape factor which is originally proposed by the Mayer-Hoff and it is given in the table. So, remember that and then we will put this value. So, finally, we will get the C2 is equal to 40, NC2 is 5.14, then 1 plus 0.2 into 2 by 3, then plus now it is the unit weight gamma 1 and water table is at the surface. So, gamma 1 basically will be 20 minus 1. So, now this will be gamma sat, because water table at the surface we have to take the effective pressure. So, and then df is equal to 1, h is equal to 1 and this is 253 kilonewton per meter square. And remember that here, as I mentioned, during the QB calculation we have taken the contribution of df and h both. So, we have to subtract that gamma 1 h in our basic equation. But if during the calculation of QB, if you do not consider the h effect, okay, you consider only gamma 1 into df, then no need to subtract this gamma 1 h. Either you subtract from here during QB calculation, or you subtract from your basic QU equation. Do not subtract twice. Okay. So, this is 253. Now I will calculate the QT. QT if the foundation is placed on the top surface, and the QT calculation is again your QT expression is C1 NC1 SC1 plus gamma df NQ1 SQ1 plus half gamma 1 B in gamma 1 and S gamma 1. Okay, this is general equation, but in the top layer you now if your C is equal to 0. Now, if C1 equal to 0, because your case sorry phi 1 equal to 0, phi 1 equal to 0. So, again these conditions will be applied, that n gamma 1 will be 0. So, I can write that n gamma 1 will be 0. Now, NQ 1 will be 1 and NC 1 will be 5.14. Okay. So, now if I calculate the QT in this condition, so it will be C 1 or 5.14, that is bearing capacity, then Cu 1, then the Scu 1. Scu 1 is the same as Mayer-Op recommendation, which is 1 plus 0.2 B by L, then plus here only the df 1. Okay. So, gamma df, because it will be not df plus h, because it is on the top layer, that is why df only. If it is in, because that is the depth of foundation. If it is the bottom layer, then the surcharge is considered as because in the bottom layer it is considered that as if the foundation, because if you look at the original derivation, your these stresses are going like this, like a straight line. Okay, it is assumed it is these stresses or the soil are moving along a straight line or a straight zone or strip where the dotted lines are there. So, that means all the stresses actually is acting on the bottom of the on the bottom layer exactly within the same width equal to the width of the foundation. Okay. So, you can question that when you apply the load, then the stresses will be distributed. So, the loading area on the second soil or the second layer may be more, but actually as it is assumed that there will be a punching kind of failure. So, the total soil along with that foundation will deform within a zone given by these dotted lines. Okay, these dotted lines which are straight. So, that means this total soil along with that foundation. So, that means that stresses will be exactly on the bottom layer, where the width of the stress which is acting on the bottom layer will be equal to the width of the foundation. That is why always we are taking B. Okay. Either it is a top layer or it is a bottom layer. So, that is why during QB calculation also we have taken B, and as I mentioned that is H. That is why when I calculate the QB bottom layer, as the it is acting on the at a depth of, because now your footing depth will be df plus h. Okay. But the top layer your footing depth or depth of footing will be df, but bottom layer it will be df plus h. That will be the footing depth for the bottom layer. That is why bottom layer it is df plus h, and for the top layer it is only df. Okay. And we have subtracted the we have taken the h contribution twice. That is why you have to subtract once that one, either during QB calculation or from the basic equation. So, now this is the equation. So, finally, I can write this is the safe factor and then gamma 1 into df. Okay. Because again the SQ1 will be as for phi equal to 0. So, your Kp equal to 1. So, SQ1 will be equal to 1. Similarly, SQ2 is equal to 1 also. So, I can write df into that part is 1. So, and then 5.14 C1 is 100 because C2 is given as a 40 kPa. So, C2 40, C1 is 100, and then 1 plus 0.2 into 2 by 3 plus again it is at the ground surface. So, this will be df is equal to 1. So, this is 1, this is 592.5 kilonewton per meter square. So, your bearing capacity of this layer soil cannot be more than 592.5 kilonewton per meter square. It has to be less than that. Let us see whether it is coming less than that or not. And another question I want, another thing I want to mention, that here the water table is considered the ground surface. If it is not the ground surface, slightly below that, but within the ground and the base of the foundation, then this surcharge or effective overburden pressure you have to calculate accordingly. Okay. So, now I can put this value in my original equation QB. So, QU is QB. So, QB is 253. Okay. Now, this is 1 plus 2 by 3. Okay, 1 plus 2 by 3. Now, we have to calculate CA and Ks. Otherwise, we cannot calculate the value. Let us calculate the first CA and Ks, because here Ks will not be required. You can see that your phi 1 is equal to 0, phi 1 equal to 0. So, tan phi will be 0. So, this total term will be 0. As the phi 1 equal to 0, so tan phi is also 0. So, this total term will be 0. Okay. So, you have to calculate the CA. So, let us see. So, calculate the CA. For CA calculation, we should know Q2 by Q1. Okay. Now, what is Q2 by Q1? So, as it is mentioned that Q2 by Q1 is what? Q2 by Q1 is when the foundation is a strip footing resting on a soil at the surface. Okay. So, now and for individual layers. So, for if I place the foundation on the second layer as if there is no other layers present, only the second layer is your soil layer, and if I place the foundation over there and it is a surface footing, so second term will be 0. Now, here in this case it is phi equal to 0. So, your third term will be also 0. So, only the first term, and the first term will be what? First term will be, it is a strip footing. So, shape factor also will not consider. So, you will be C2 NC2. So, that is the only Q2 value. Second term will be 0, third term will be 0, first time is a strip footing. So, you will not consider the shape factor. Even if you consider the shape factor, does not matter, because it is the ratio, it will cancel out. So, now for the Q1 first layer, if I put on the first layer, the same thing will happen, it will be C1 NC1, but both the cases as the phi is equal to 0. So, NC2 will be equal to NC1 and both the cases will be 5.14. So, it will cancel out. So, for if both the layers are cohesive soil, then it will be simple the ratio of the cohesion. Okay. So, C2 by C1. Now, here your C2 is 40 kPa, C1 is 100 kPa. So, this is 0.4. So, now let us see if it is 0.4. Now, this value is 0.9. So, your Q2 by Q1 is 0.4 and CA by C1 is 0.9. So, I can write that my CA by C1 is 0.9. So, CA will be 0.9 into C1. So, 0.9 into 100. So, it will be 90 kilonewton per meter square. So, now if I put this value, that my original equation I am now putting this value. So, this term is 0, as I mentioned your phi 1 is equal to 0. So, it is only this term and then minus gamma 1 h, because we have taken h contribution during QB calculation. So, we have to subtract. So, this is 2 by 3 into 2 into 90, df is equal to 1, b equal to 2 meter, then plus this whole term is 0, then minus gamma 1 into df or into h, and this is effective unit weight we have to consider, h is equal to 1. So, finally, this equation will be the value will be 393 kilonewton per meter square, which is less than the 592.5 kilonewton per meter square. So, finally, Q u will be equal to 393 kilonewton per meter square. So, this is the value that we are getting if both the soils are cohesive soil, and then we have considered that obviously this equation that I have derived is valid if the lower layer is the softer layer compared to the upper layer. So, this is my case 1 where we consider both the soils are clay. Okay. The upper layer is stiff clay and the lower layer is the weaker or the softer clay. Now, the case 2, I will go for the case 2 where it is a phi C soil. The same problem, I have only changed the properties of the first layer. Okay. So, for the first layer is obviously the stronger sand layer. Stronger layer of phi equal to 40 degree. Okay. Gamma sat is equal to 20 kilonewton per meter cube, and gamma bulk is 18 kilonewton per meter cube, because here I am considering the water table is not at the ground surface like the previous case, it is below the ground surface. Just to show you how we can solve the problem in such case. Okay. And water table is at the base of the foundation. Water table is at the base of the foundation. Okay. So, let us see how we can do that. So, before I go to the calculation here, you cannot use that the basic equation that I have given directly, because here you have to do some slight modification, because your earth pressure values are, because in earth pressure there is only gamma 1 term, but now here the gamma will be the different, because water table is present. So, let us see that first calculate the earth pressure, then we will put that value in your equation. So, I will show you how we can calculate the earth pressure. So, this is your ground surface, obviously the same problem we are taking. So, your dF is equal to 1 meter, and this is the layer, first layer, and the second layer interface. So, where h is equal to 1 meter, okay, and water table is at the base of the foundation. Okay. And here the unit weight is 18 kilonewton per meter cube, and here the saturated unit weight is 20 kilonewton per meter cube. So, gamma sub will be 10 kilonewton per meter cube, because unit weight of water is 10. So, this is the earth pressure distribution. So, for this portion it will be 18 into 1, this will be 18 kilonewton per meter square, and here it will be your 18 kilonewton plus 10 into 1. So, this will be 28 kilonewton per meter square. So, the water table effect or water effect we will not calculate during the earth pressure, because we will consider only the soil part, because water will just increase your bearing capacity. So, that is not recommended, because water may not present in this sometimes also, that is the only, but during your earth pressure calculation you have to consider the water pressure, because that will reduce your factor of safety. But here if you consider the water, that will increase your factor of safety. So, that is not a good thing. So, that is why we will consider only the soil contribution. So, but you can ask why I am not using the directly that expression here, because if the gamma are same for top and bottom of this zone, then you can directly use that expression. But here the gamma part and here the gamma part are different, because of the water table position. That is why you have calculated separately. If the gamma is same for throughout the soil, then you can use the your basic equation that is given by using the same gamma. But here the gamma value is different. So, that is why you are calculating in this way. So, this is my passive pressure zone. Okay. So, now I will calculate the gamma B. Okay, gamma B will be the same value, because your slightly it will change, because previously water table was at the ground surface and now the water table as the base. So, at the base of the foundation, slight change will be the in the QB value. So, my previous example, you can see QB is basically this is the equation. So, here only this part will change. Okay. So, now initially it is dF plus H, both are same gamma, but it is a different gamma now. So, only this is the change. So, gamma value QB will be 40 into 5.14, 1 plus 0.2 into 2 by 3. Now, the change is there. This portion is same, 40, 5.14, 1 plus 0.2, 2 by 3. Now, this portion will slightly change. For the top one, that is gamma into dF, that is 18 into 1, because that is above the water table. Gamma bulk means the above the water table, and then the saturated one, that is submerged 20 minus 1 into 20 minus 10 into 1. Okay. So, that will give you 261 kilonewton per meter square. So, I have calculated the QB part. So, in this case, and I have also shown that how I will calculate the passive pressure resistance part. So, next class I will complete this case 2 problem, where I will also show how I can calculate the QT, then how I can calculate the Ks, and then because K again Ca will not be required here, because your C1 is here, you can see that C1 value is 0 here. So, it has phi 1 and gamma, okay. And here the second layer, your phi 2 value is equal to 0. It is C2 and the gamma 2 or gamma, here also gamma 1. So, Ca will not be required, but only the Ks will be required. So, that I will discuss, and then we will go in the next class, we will go to the few more cases, okay, because I have discussed 4 cases. So, I have finished the example for first case, I am doing the second case, that will finish in the next class, and then I will discuss the other 2 cases. Thank you.